constructing classes for frequency distribution. We start with the class width. The class width begins with a formula where we take the largest data value in the data set and subtract the smallest data value in the entire set. This calculation, some of you may recognize as being something called the range. It actually tells you the size of the section of the number line. If we were to lay out all the different data values, it tells you the size of the portion of the number line on which the data lies. What we want to do then is to separate that section of the number line into equal size pieces, one for each class that we're going to create. So we take that total range and divide it by the number of classes. Now, division often produces a fraction or a decimal. It does sometimes produce a whole number as well. Regardless of the value that we get, we are always going to round this value up. Now, in a future video, I will explain why it is we always round up. But for now, I will simply show you some different examples of different numbers of classes we might use and how the result of this calculation will come out and how we always round up. So, we're using the drive-through service time data, and the largest value in the data set is 308 seconds. The smallest value in the data set is 83 seconds. Now, we're actually going to use this data set for this example in this data set for a number of things throughout this chapter. And we will use the 6 classes to do it. Now, the number of classes will always be given to you at this stage of statistics. If you were an advanced enough student in statistics, you might be given the freedom to choose how many classes you want, or you might be told to experiment with a different number of classes to see what effect that has on the appearance of the data set. But for now, you will always be told how many classes to use. Moving forward in future lessons, we will be using 6 classes, so that's what I'm going to start with here. So, always feel free to use a calculator. It's at your disposal. Might as well use it. 308 minus 83 is 225. $225 then, divided by 6. Well, let's see. 6 would go into 210, 35 times. So this should go in 32.83 repeating times. Let's just double check that. Again, always a good idea to pull out a calculator. Excuse me, wow, my math is terrible today. 37.5, excuse me. Happens to the best of us. Now, that does not mean that the class width is 37.5. It is not. We will always go a little bit bigger than this. In this case, we will go up to 38. Now, in this case, that might seem obvious because if we were rounding 37.5 to the nearest whole number, of course we would go up to 38. Suppose we had a different number of classes. Suppose, for example, that we wanted to use 7 classes. It's still the same range of values. We haven't changed the data values at all. They still span the same range. We're just changing how many sections we are splitting it up into. 225 divided by 7 now is 32.14, and a whole bunch of other decimal values. They actually aren't very important at this point. In this case, typical rounding might suggest that we round down to 32. But if we round down, the classes will not be big enough to include all of the data values in the set. That will again be demonstrated in a future video. So what we will do is we will round up. We always round the result up, no matter what the decimal places are over here. No matter whether they would normally tell us to round down or not, we always round up. Now, occasionally, division does actually result in a whole number. You might think that that's great and that we can leave it where it is. Excuse me. Suppose we were using 5 classes. 225 does actually divide by 5 perfectly. If we're using 5 classes, 225 divided by 5 is 45. But that is not our class width. Again, this one's trickier to understand, and I will demonstrate this in a future video. We will again round up. We always round up. Whatever value we get out of here, we always go to the next, well, in this case, whole number. The reason we're using whole numbers here is because the data set is in whole numbers. If the data set was measured to 2 decimal places, we would round up to 2 decimal places.